In senior design this semester, MB9 was tasked with making an active magnetic bearing. It had to have float and lock modes, controlled wirelessly using a Texas Instruments TIVA C series. The physical system consists of 3 magnets for holding the bearing, 3 sensors for keeping track of distance, 4 lithium-ion batteries for power, a TIVA for computation and control of the system, and some power circuitry. From the high rail, a 5-volt regulator was used to power the sensors and TIVA. The circuit shown takes a PWM output and converts it to an analog current source for driving the magnets.
So here you have our prototype design. We have the 3 12-volt electromagnets on the corners of our acrylic. Right next to them are our IR sensors, which give us distance information. The logic is all on the TIVA microcontroller here, and on the second layer you can see the electronic circuitry that integrates this board with our magnets. On the underside here is our 16-volt DC battery pack, which supports our 4 batteries. We have a Bluetooth module here for wireless implementation, and we also have an IR chip for similar purposes. Note a special switch here can change between the Bluetooth and the IR implementation. On the top side we have a shield on this side to protect your hand from the regulator behind it, which gets relatively hot. And lastly, these 2 buttons here will control the mode of the magnets. So when you flip the main power switch, which is found here, the magnets are off. Pressing these buttons will turn them on and off to keep us in power save mode. Next up, you'll see the device in operation.
Before we show it to you, here's how it works. There are 3 controllers being run independently. Each takes the sensor data and finds the difference from where the bearing wants to be. The difference is fed into a lead compensator to determine how much current is needed. That current is converted to a duty cycle to output the appropriate PWM signal. The user varies the desired distance via either Bluetooth using our app or infrared using the SIRC protocol.
So here's our Bluetooth app. We have 2-way Bluetooth communication. If I press this button, the bearing will send back a message saying that it's still running. You can see up here it tracks the height, so if I move it up, you see the height go up. Both places I can move it back down, move it back up. I can lock, and it'll go to 0, and unlock, unlock, and unlock, and turn off the height tracking if you don't want to see that. Go down and up. So this is flipping the switch from Bluetooth to IR wireless control. He has an IR app running on his phone, and he's going to show you the device locking and unlocking using IR communication. And now he switched the device back to Bluetooth control, and you can see IR no longer controls the device.
As you can see, the prototype is still supported with an extra 200 grams as pictured here.